Today we will be studying about laws of chemical combination. Under this topic we will discuss three laws, namely the law of conservation of mass, law of constant proportion and Dalton's atomic theory. First, let's discuss about the law of conservation of mass. This law was given by Lavoisier in 1774. He stated that mass can neither be created nor destroyed in a chemical reaction, which means the total mass of the reactant is equal to the total mass of the product. Here, the reactants are the substances which combine together in a chemical reaction, and the product is the new substance formed as a result of chemical reaction. Here we have taken an example in which hydrogen and oxygen combines to form water. So, as stated, according to this, the law of the sum of the masses of hydrogen and oxygen will be equal to the mass of water molecule. Now, let's understand this law by an experiment for better understanding. In this experiment, calcium chloride solution is taken in a test tube placed inside a conical flask consisting of sodium sulfate solution, and the test tube is then tied with a thread and the conical flask is fitted with a rubber cork. This whole thing is weighed, but before placing the solutions, the weight of the whole arrangement is taken and subtracted from the weight obtained after placing solutions so that we can get the total mass of the reactants. Then after that, we tilted the test tube and observed that the calcium chloride mixes with sodium sulfate and white precipitate of calcium sulfate is formed. And again, this arrangement is weighed in a similar manner as in reactants case. The weight obtained is the weight of the product. So, from this experiment, we observe that the chemical reaction took place as shown and the total mass of the reactant is equal to the total mass of the product. As here, 20.8 gram of calcium chloride reacted with 14.2 gram of sodium sulfate to give 23.3 gram of calcium sulfate and 11.7 gram of sodium chloride. Hence, the mass was 35 gram before as well as after the reaction. Hence, this verifies the law of conservation of mass. Now, let's solve a problem related to this law, which will be helpful for you to solve various problems related to this law in your examination. Here we have taken an example from NCERT textbook. So the question is, sodium carbonate reacts with ethanoic acid to form sodium ethanoate, carbon dioxide and water. In an experiment, 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid to form 8.2 gram of sodium ethanoate, 2.2 gram of carbon dioxide and 0.9 gram of water. Show that this data verifies the law of conservation of mass. So let's first write down the reaction. Here, sodium carbonate and ethanoic acid are the reactants, and when they react, we get the products as sodium ethanoate, carbon dioxide and water. Now we have to confirm that this follows the law of conservation of mass. Sodium carbonate is reacting with ethanoic acid. Let's calculate the mass of the reactants first. The mass of sodium carbonate here is 5.3 gram and that of mass of ethanoic acid is 6 gram. When they combine, their addition results 11.3 gram. Now, let's calculate the mass of the products. Here, the products are sodium ethanoate, which is having mass 8.2 gram, carbon dioxide with mass 2.2 gram, water with mass 0.9 gram. On adding them, we get 11.3 gram. This verifies that this equation follows the law of conservation of mass. Further moving towards the second law of chemical combination, that is law of constant proportion, also known as law of definite proportion. This law was given by Joseph Proust in the year 1774. He stated that in a chemical substance, the elements are always present in definite proportions by mass. It means that whatever be the source from which it is obtained, or the method by which it is prepared, a pure chemical compound is always made up of the same elements in the same mass percentage. For example, water is a compound which always consists of the same two elements, hydrogen and oxygen, combined together in the same constant proportion of 1:8 by mass. That is, 1 part by mass of hydrogen and 8 part by mass of oxygen. Let us discuss this in a little more detail. We know that water is a compound. If we decompose 100 gram of pure water by passing electricity through it, then 11 gram of hydrogen and 89 gram of oxygen are obtained. Now, if we repeat this experiment by taking pure water from different sources like river, sea, well, etc., the same masses of hydrogen and oxygen elements are obtained in every case. This experiment shows that water always consists of the same two elements, that is, hydrogen and oxygen, combined together in the same constant proportion of 11:89, or when we reduce it, we get 1:8 by mass. And this is the law of constant proportion. We can take another example of ammonia formation. Ammonia is a compound. It has been found by analysis that ammonia always consists of the same two elements, nitrogen and hydrogen, combined together in the same ratio of 14:3 by mass. Now, let's solve a sample problem related to this law. So, the question is, in an experiment, 1.288 gram of copper oxide was obtained from 1.03 gram of copper. In another experiment, 3.672 gram of copper oxide gave, on reduction, 2.938 gram of copper. Show that these figures verify the law of constant proportion. So, first we will solve for the experiment. Here we will first calculate the mass of oxygen by subtracting the mass of copper from mass of copper oxide, which are given in the question. So, by solving, we got the ratio of mass of oxygen to the mass of copper as 4:1. Similarly, we will calculate the ratio in the second experiment. First, by calculating the mass of oxygen from the given values of copper oxide and copper, and by solving them, we got the ratio of mass of oxygen to the mass of copper as 4:1. So, by both the experiments, we got the same ratio of masses of oxygen and copper, that is 4:1. Hence, this law is verified. Moving on to the Dalton's atomic theory. In order to explain the two laws of chemical combination, Dalton put forward his atomic theory of matter. His first postulate states that all matter is made up of very small particles called as atoms. Here you can see all the states of matter, whether solid, liquid or gas. They are made up of atoms. His second postulate states atoms are indivisible and cannot be created or destroyed. And by this postulate, he explained the law of conservation of mass. Since an atom cannot be created or destroyed, therefore, the number of various types of atoms in the products of a chemical reaction is the same as the number of all those atoms in the reactants. The same number of various atoms in products and reactants will have the same mass. So, the total mass of product is equal to the total mass of reactant. This explanation will become much clearer through an example. Here we have taken an equation of decomposition of calcium carbonate. As you can see, calcium carbonate have 1 calcium atom, 1 carbon atom and 3 oxygen atoms in the reactant. The product of its decomposition, calcium oxide and carbon dioxide taken together also contain 1 calcium atom, 1 carbon atom and 3 oxygen atoms. Now, since the number of various types of atoms in the products and reactant remains the same, therefore the mass of products and reactants also remains the same in this reaction. Hence, law of conservation of mass is verified. His third postulate stated that the relative number and kinds of atoms are constant in a given compound. By this postulate, he explained the law of constant proportion. Since the number of atoms, the kind of atoms, and the mass of atoms of each element in a given compound is fixed, therefore, a compound will always have the same elements combined together in the same proportion by mass. This explanation will become much clearer through an example. Here, we have taken an example of water formation. This postulate states that hydrogen element consists of hydrogen atoms and oxygen element consists of oxygen atoms, and two hydrogen atoms always combine with one oxygen atom to form water molecule. Since a water molecule always contains the same number of hydrogen and oxygen atoms, each atom having a fixed mass, therefore the masses of hydrogen and oxygen elements in water will be in constant proportion. Hence, law of constant proportion is verified. His fourth postulate states that atoms combine in the ratio of small whole numbers to form compounds. Like, for example, hydrogen combines with the oxygen in the ratio of 1:8 to form water. His fifth postulate states that all the atoms of a given element are identical in mass, size, and chemical properties. Means, if we take two atoms of hydrogen element, then they will have the same mass, size, and chemical properties. His last postulate states that atoms of different elements differ in mass, size, and chemical properties. Means, if we take an atom of argon, an atom of calcium, and an atom of potassium, then all will have different mass, size, and chemical properties. Lastly, if we look into the drawbacks of Dalton's atomic theory, there are three drawbacks. One of the major drawbacks of Dalton's atomic theory of matter is that atoms were thought to be indivisible. But now we know that under special circumstances, atoms can be further divided into still smaller particles called electrons, protons, and neutrons. So, atoms are themselves made up of three particles, namely electrons, protons, and neutrons. The second drawback is that, as he said, that all the atoms of an element have exactly the same mass. It is, however, now known that atoms of the same element can have slightly different masses, called as isotopes. Here we have taken an example of isotope of hydrogen, which are having same atomic number but different masses. Example: hydrogen, deuterium, and tritium. The third drawback is that, as he said, that atoms of different elements have different masses. It is, however, now known that even atoms of different elements can have the same mass, called as isobars. Here we have taken one example which consists of argon, potassium, and calcium atoms. All are different atoms, but we have same mass. Hence, after all these discussions, hope you understood the laws of chemical combination and Dalton's atomic theory. To evaluate what you have learned so far, the link of the text is mentioned in the description box below. Enroll yourself today to have live interactive sessions at Cerebral Science Academy. You can also contact us at our number 9311517934, or you can email us at info.cerebralscience@gmail.com. Thank you.